All right, let's go on to page 31 when we're done. So we're going to start with an old school, elementary school type division problem so we can talk about process and how even though polynomial long division looks horrific, it's actually easier sometimes than the plain old long division. So we have this, 5,467 divided by 13, something you should totally be capable of doing. So we take 13, he's outside the house, 5,467 inside the house, right? And then I have to divide 13 into that. So I try 5. 13 doesn't go into 5, right? But 13 can go into 54. So I know 3 times 13 is 39. What's 4 times 14? I'm sorry, 4 times 13. 52. So 52 sounds like where we're going to have to go with this, right? So we're going to do 4 here, goes above the 4 because I'm dividing into 54. Where you put it matters. 4 times 13, we just said, is 52, okay? And then I know you think about this as subtraction, which it is. But what we're really doing is going through here and changing the signs on the numbers and then adding them. If you think about it that way, the process ends up being the same. So when I do that, this becomes 2, and I bring down my 6. Then 13 goes into 26 twice. 2 times 13 is 26. I change the sign on the second one, and then I add them, and I get 0. Does that mean that my answer is 42? No, it does not, because I have not brought 7 down yet, and I haven't filled in all my slots. That's why it's important that you put them in the right places so that you don't do something weird like that, because that's where some weird things happen sometimes. 13 goes into 7 how many times? 0 times. And then 0 times 13 is 0, so you're left with 7. So your answer then, in the end, is 420 and what? 7 over 13. Make sense? The exact same process happens with the polynomials. Well, exact. Kind of exact. Obviously, there's variables and there's a few different changes, but the point is, it's actually a little bit easier because then over here, we don't have to know what 4 times 13 is. And I know that was really taxing on some of our brains. So we're going to come over here. Outside the house goes x plus 4. Inside the house goes 3x cubed plus 2x squared minus 37x plus 12. We good with that? Bless you. Now this 13, there's only one term here. Over here, we have 2 terms, right? But we only worry about the first one when we're figuring out the division here. So I take this first term, which is 3x cubed. I divide it by this term, which is x. What's 3x cubed divided by x? 3x squared. So I put it above the x squared term, 3x squared. And then I multiply back, just like we did over there. 3x squared times x, 3x cubed. And then 3x squared plus 4, 12x squared. Then I go through and I change the signs on those 2 terms there. These 0 out. And then 2x squared minus 12x squared is negative 10x squared. Then I bring down the negative 37x. Then I do it all over again. Negative 10x squared divided by x is negative 10x. Multiply it back, and I get negative 10x squared minus 40x. Then I change the signs on both. Now, you could put a negative out front with parentheses and all that. You don't need to do all that. Just go through and change the signs. It's the same thing. These 0 out. This gives me 3x plus 12. Then 3x divided by x is a positive 3. So this gives me 3x plus 12. I change the signs. That zeroes out. That zeroes out. I get 0. So my final answer then is 3x squared minus 10x plus 3. What questions do you have? Knocking the cobwebs off, right? This is not brand new information. Okay, let's look at number 5. So again, so the difference here between 4 and 5 is that 4 had an a value of 1 here, and this one does not. But we'll see that it doesn't really matter. 2x plus 7 divided into 2x cubed plus 5x squared minus 19x minus 42. All right, so I take the first two terms. 2x cubed divided by 2x is what? X squared. So x squared goes right here. Then I multiply it back, and I get 2x cubed plus 7x squared. What do I do next? Change the signs. Right. So then these zero out. This gives me negative 2x squared minus 19x. And negative 2x squared divided by 2x is what? Negative x. So I get negative 2x squared minus 7x. Go through and change the signs. Those zero out. Negative 12x. Bring down my negative 42. Then negative 12x divided by 2x, negative 6. Negative 12x minus 42. Change the signs on both. Those zero out. You get 0. Which means my answer is x squared minus x minus 6. Now, 4, like I said, could be done with synthetic division, which we'll review on Monday. 5, you can force it, but we're not going to force it. It's not worth it. 6, you could not. Okay, so that's why you might as well just know long division. Most of the time, you don't remember the pattern for synthetic anyway, but we will go over it for those of you that will. All right, so here we got x squared instead of just x. That's fine. Plus 8. Divide that into x to the 4th. Plus 3x cubed plus 4x squared plus 24x minus 32. All right. So, same process here. X to the 4th divided by x squared is what? X squared, and it goes above the x squared term. Way down there. So then x squared times x squared is x to the 4th. X squared times 8 is 8x squared. And it goes under the x squared term. It's very important that you line them up correctly. You can have horrific handwriting and still have organized work. Trust me, see it all the time. So then I go through and I change the signs here. These zero out. This is like a 0 term in here, so basically I have 3x cubed minus 0, so this is just 3x cubed. And then this will give me negative 4x squared, and then I bring down my 24x. Everybody with me? Any questions? All right, so then 3x cubed divided by x squared, positive 3x. Multiply it back. I get 3x cubed plus 24x. And I change the signs. Those zero out. Then negative 4x squared, negative 4x squared. Those zero out right there as well. That's fine. And then I just bring down my negative 32. So then negative 4x squared divided by x squared is negative 4. Negative 4x squared minus 32. Those zero out. I'm sorry, I changed the signs and then they zero out. I get 0. So my answer is x squared plus 3x minus 4. Now, all of those that we've done divided evenly. When we start applying this, they won't divide evenly. We don't want them to divide evenly. If they divide evenly, then we did something wrong, okay? So that's just to kind of get us a little refresher. Let's go look and see what we do with remainders here. All right, so we're doing the same because you don't know it's any different when you start. X plus 1 goes on the outside. On the inside, we have 3x cubed plus 7x squared plus 2x minus 7. So 3x cubed divided by x, 3x squared. You can go ahead and just do this without me, most of you. 3 times 1, I'm sorry, so 3 times x, 3x squared times x, 3x cubed, then plus 3x. Change my signs. Those zero out. You get 4x squared. Bring down my 2x. Then 4x squared divided by x is 4x. So then this gives me 4x squared plus 4x. I change the signs. Those zero out. Negative 2x minus 7. Negative 2x divided by x is negative 2. So that gives me negative 2x minus 2. Change the signs. Those zero out. This gives me a negative 5. Okay. So then my answer is 3x squared plus 4x minus 2 plus, because you always add the remainder. You always add the remainder. And then the remainder is negative 5 over what? X plus 1. Here, I'm going to rewrite that. It looks like it's all blending in together. I'm rewriting the same thing, though, so it's not like I'm changing it. I'm just going to move it. So I had 3x squared plus 4x minus 2 plus negative 5 over x plus 1. You want to always add, because if there's more than one term in the numerator and you just willy-nilly put your negative signs different places, you could easily be wrong. Okay? Any questions? We're good? All right, then you do number 8 on your own. Uh-huh. Oh, yeah. Thank you. Right here. This should have been a 3x squared. And because it's there and I used it here. And yes, thank you. Sorry about that. So I'm going to work it too, but I don't want you just copying mine down. I'm going to want you to check it when you're done. So when you're done, check yourself with me. Like I said, don't just copy it down. Let me know if you have questions. If you did something weird, make sure that you figure out where that something is. And remember that so you don't do the weird thing again. And just keep going. Same process over and over again. I have your name on there. I put your ID number on your phone too, make it easier. You good? Kind of? All right, anybody have any questions for me? Okay. Well, it's important to line them up. Okay. All right, let's move on to number 9. Now, number 9 looks even worse than the rest, and they all look pretty bad, right? But it doesn't mean that it's difficult. This doesn't mean that it's any more difficult just because the expressions are longer. So what I'm dividing by is x squared minus x minus 5. I'm going to divide that into x to the 4th minus 5x cubed plus x squared plus 20x minus 10. Go ahead and do this without me if you can. If not, I will talk you through it. So I have x to the 4th divided by x squared is x squared. X squared times x squared is x to the 4th minus x cubed minus 5x squared. Go through and change my signs. And I get negative 2x cubed plus, no I don't. I was doing the 5 minus the 3. That's not how that works. Negative 4x cubed plus 6x squared, right? And I hope whoever said, what, behind me, would have actually stopped me if I kept going. Then I bring down the 20x. I caught myself, but I also heard that, which is fine. So then negative 4x cubed divided by x squared, negative 4x. So then I get negative 4x cubed plus 4x squared plus 20x. Then I change my signs. Those zero out. This gives me 2x squared. These zero out, that's fine. But then this negative 10 comes down. Okay. So then 2x squared divided by x squared is 2. So this gives me 2x squared minus 2x minus 10. Go through and change my signs. Those zero out. 0 plus 2x is 2x, and those zero out. So I hope you see the importance in actually lining things up correctly, or you can get yourself all kinds of confused. When we're done, we get x squared. Maybe? No. X squared minus 4x plus 2 plus 2x over what? X squared minus x minus 5. That's my answer. What questions do you have? Now, if you are a polynomial division whiz and all that was, you're just like amazing at this, which hopefully that is the case for the great majority of you, that's all fine and great, but if you don't pay attention to what we're doing this next time, it doesn't matter how good you are at doing this because you're going to get the wrong answers, okay? Not next time, but in this next section. Because this is when we have, what if we have a missing term or more than one missing term? You have to take that into account. So if you notice here, we've got an x to the fourth, which means if it's in standard form, I have x to the fourth, x cubed, x squared, x, and a constant. There's no x cubed term in here, right? So I have to put a placeholder in there. It doesn't matter if I have missing terms on the outside. It matters about what's on the inside. So x minus 8, and I'm going to divide this into, right, so when you start writing these, I'm going to write x to the fourth. The next thing, I have to have an x cubed term. There is not one in this polynomial, so I have to put plus 0x cubed. You have to have a placeholder. Then I need an x squared. I have that. That's negative 64x squared. Then I need x. I got that. Plus 9x. Then I need a constant. I got that. Minus 80. Okay? In long division, you usually catch yourself if you left it off because then things get weird. You don't catch yourself in synthetic division. You just get the wrong answer. Well, sometimes when things get weird here, then people just make up math and you still get the wrong answer. But all right, so x to the fourth divided by x is x cubed. So I put it above my x cubed term. Then this gives me x to the fourth minus 8x cubed. I go through and I change the signs. These zero out. So 0x cubed plus 8x cubed is 8x cubed. I bring down my negative 64x squared. Okay. So then 8x cubed divided by x is 8x squared. So then I get 8x cubed minus 64x squared. Change the signs on both. Those zero out. Those zero out. I bring down my 9x. Okay. So since they both zeroed out, I have to actually bring down both of these terms. And when I do 9x divided by x, I get 9, so I put it above the constant term. So then I get 9x. What's 9 times 8? 72 minus 72. Change the signs. Those zero out. I get negative 8. Okay. So basically I have a 0x term in there, which you never have to write, but that's why there's a space there. So then when we're done, we've got x cubed plus 8x squared plus 9 plus negative 8 over x minus 8. Ooh. There's my answer. What questions you got? We good? Don't forget about, yes. Right, yeah. So there's no, because since these both zeroed out and the next thing I brought down, I got a 9, there's nothing here, so we just kind of skip over it and go to the next one. Because what's really there is plus 0x, right? Because this gives me 0 right here when I do that. And then I say, okay, 0 divided by x gives me 0, and then that's why we bring down the 9x. We just kind of skip, actually put it. No, you do not. When you're doing this, now some people may choose to right here just because it keeps things spaced out. There's absolutely nothing wrong with it. And even if you wrote it in your final answer, it wouldn't be wrong. It would just, you would never see it that way. Okay, but if it helps you keep things lined up, absolutely you can write it up there. And just leave it off when you come down here. That's a good question. Anything else? All right, so you do the last one on your own while I'll hand out the assignment, and then I'll come back up here and work it so you can check yourself. Okay, pause where you are. Make sure you have it set up like that before you get any farther. If not, fix yourself and then continue. And as long as you have it set up that way and you're working through it, keep going. Okay. So when you're done, check yourself with me. If we agree, you're good, go ahead and tape it in and you're done. If we don't agree or you have questions, let me know. And then you have your assignment and lots of time to work. Make a good use of that time.